For part one of this assignment, talking about the ISTE standards, when thinking about assessments and things like that, um, I think about standard 1.5, which is the computational thinker. In terms of mathematics, being a computational thinker is very important in the fact that students need to be able to break down a problem into all of its components in order to answer the question completely. The use of technology in my TPAC lesson plan is vital in reinforcing the material that was given to students during direct instruction. The the state standard that I'm using for this lesson is part of the California Common Core State Standards for Algebra 1. The standard states that graph functions express symbolically and show key features of the graph by hand in simple cases and technology for more complicated cases, meaning graphing calculator or a program such as Desmos. Graph linear and quadratic functions and show intercepts, maxima, and minima. This standard encompasses a lot of information in regards to quadratic equations, which are a huge backbone in Algebra 1 and in the Algebra 1 standards. You must know how to manipulate, graph, solve quadratic equations coming out of Algebra 1 into Algebra 2 to show your mastery of Algebra 1. As a reminder, let's just go ahead and look over my TPAC lesson plan once again. That lesson plan is to use a program called Desmos, which is an online platform that we use for math. What it does is it gives a prompted questions for students to work together, work individually throughout the lesson. I have the ability to pause students at any given time through the teacher side of the program, as well as completely lock students' iPads using Apple Classroom, which gives students a good opportunity to make sure that one, they are always on task, or two, that they are proceeding along the assignment in the rate that they should be doing so. Looking at what the lesson would actually entail, there would be a warm-up based on their prior knowledge of graphing quadratics, and then we would move into the Desmos program, which gives students prompted questions, and I have specific places that I pause the lesson to engage students in pair-share conversations as well as large group conversations. When planning for assessments, using formative assessments throughout this entire unit or entire chapter is essential. For this standard, I would have students complete an exit slip for after the Desmos lesson that they did in class. The exit slip would be very similar to one of the types of questions that they would see on their unit test, for example. Once students have turned in their exit slip, I would look at it based on completion, not grade it based on accuracy as of right then, because the following day I would hand back that exit slip to the students so that way they could self-correct. And in that self-correction, I would walk them through how to best complete each part of the problem. During this, I could ask questions such as, how do you know that this point, or 0.32 or what have you, lies on the parabola with only knowing this other point? These types of questions are essential because students need to then realize, well, if this point is this distance from, let's say, the axis of symmetry, then the other one has to be the same distance, which then brings students to realizing that symmetry is really the key aspect in graphing a parabola without plugging in x values and getting a bunch of y values out, or a table of values as we all know it. Once we have gone over that exit slip, I would give students a similar but different question as a warm-up that I will collect and give them individualized written feedback on. As far as the summative assessment for this lesson, it would be used as a complete chapter test, which would revolve around all of quadratics. It's usually a very large test. That includes 80% questions where students would have to show all of their work in order to get correct answers. The other 20% would be true-false questions or basic one-step questions where I'm just really looking for knowledge on vocabulary and identification. For this uh, for math, we don't necessarily use the rubric that you might be thinking about when you see the word rubric. An answer key, a detailed answer key, is typically how we would go about about grading our students' work. As you can see, a question would look something like this. Use the following equation, show all of your work, complete all of your steps necessary to graph and solve the equation accurately. Looking at my answer key here, you can see that the graph itself is worth 5 points out of the 20 points that this question could potentially be worth. Where each one of those bulleted points brings part of the full credit answer. If one of those things is not shown on the graph or graphed itself, then that would be a lesser point. For a full point graph, that would be 5 points. You would need all of those things that you see highlighted in blue. As far as everything on the left-hand side, as you can see, all the things that I have highlighted in blue, those are the things that need to happen in order to get a full credit points on a question. As you can see, all of my work is done in green. This is just roughly what I expect to see from each student if they were to complete a question to its full potential and show all of their work. Each step in each little section of this problem is worth a certain amount of points. In order to receive full credit on every single section, you would have to do every single step that you see that I have there. As far as rubrics go in mathematics, this is typically what a math teacher would use in terms of rubric. We make an answer key, we show all of our work, and we look at what students should be doing and what we expect from students in terms of a full credit answer. Talking about reflecting on assessments, part 3. Students, how does UDL support students before and during and after assessments? Students are supported through all parts of our lesson. Students will be given feedback through entrance and exit slips throughout the chapter. Using these types of formative assessments allows students to make adjustments based on what feedback I've given them on certain problems. Students can use all the feedback they have received leading up to a chapter test to correct errors that they might have made throughout the chapter. Utilizing technology to support formative or summative assessments. I teach at a private school that does not use standardized state-mandated tests. That's one of the advantages or disadvantages, I guess you could say, of a private school. We are not state funded, therefore we don't do state mandated tests. This means that teachers, though, need to individually collect our own data in order to inform our teaching practices. One piece of technology that our math department likes to use is a program called IXL. IXL gives students an infinite amount of practice problems on any specific topic, and as the teacher, I am able to see which questions students are working on in real time, and I can then target students and provide very specific feedback to those students as to what they are actively doing wrong on that type of question, what they should look out for, what they need extra help with. It allows me to give a lot of individualized feedback throughout an entire chapter. Formative assessments are key in a high school math class. Formative assessments such as exit or entrance slips allow me as the teacher to make a decision about how to proceed in the chapter. If students are showing that they are struggling with a certain aspect of what we are learning, then I'm able to adjust my instruction accordingly. I teach in a block schedule that is 85 minutes every other day on a rotating basis. Therefore, I have a lot of time to review, adjust, and make decisions based on student understanding. Through this process of revising my TPAC lesson, I took feedback from some of my peers that made me think about using technology. As you saw through me going through this presentation, this is what students would typically do on their own iPads at school, going in and out of different programs. And while doing that in an environment where you might not be 100% certain on the topic that you are learning, going back and forth through different apps on an iPad might be a little bit cumbersome, which means that as part of my revision, I had the thought of then doing a lot of um, vocab and key definitions and writing those on the front board, so that way students don't have to flip through all of their apps while working on this lesson, and they can just look up at the board in order to see what a certain word might mean, or to get that trigger back to, oh, well, I need to do this or that for this problem. So having that visually in front of them was something that I had not thought about when writing the lesson initially, but through revising and getting feedback from peers, that is one of the things that I am happy that I had thought about. So thank you for that.